Welcome to this session. My name is Ron Bosma. I'm director of a circle at Lund University, and welcome to this session where David Rigby from the UCLA will give a keynote. Just to remind you, and of course being the director of Circle, I have to remind you that Circle is one of the sponsors of this conference, and especially from this session. Circle, as you may know, is one of the largest research centers on innovation studies in Europe and part of Lund University. And actually there are about 50 researchers working there, and many of those are actually economic geographers. So you might even say that one of the largest centers, I think, in Europe in economic geography is actually in Lund. Well, we are working on research like geography of innovation, regional innovation systems, globalization of innovation, and of course, enough about Circle. I would like to go and introduce the two contributors. Of course, we have very distinguished speakers in this session. Of course, they don't need any introduction, but just let me say a few words on Professor David Rigby, who will take off in a few minutes. Of course, he's a very well-known schooler, as we all know. He did his PhD in geography in 1988 at McMaster's University in Canada. And the thesis of his was technological change in Canadian manufacturing and regional analysis. He holds a professorship in geography and statistics at the UCLA of the Department of Geography. And I think if you have to summarize the work David is working on in the last years, is one of his main interests is the analysis of microeconomics of agglomerations. He likes to use data, microdata, plant level data, firm level data, and he explores in that type of research different types of agglomeration externalities and how that affects different kinds of plants and firms. That's one of his research interests. And another research interest is analysis of the impacts of trade on labor market areas. And there especially what draws his attention to is whether an increase in import competition has an effect on job losses, plant exits, and wage inequality. But I think his main research area is without doubt geography of invention and knowledge flows. And there I think he has made already some seminal contributions. One of them is working on the theoretical work in evolutionary economic geography. And actually you will organize a panel session later today on exactly that topic. But even more so, as I said before, David really likes to work with big data. At the micro scale, whether it is at the individual level, whether it's at the plant level, or whether it's at the firm level. So he has produced many papers already on the geography of knowledge production and knowledge flows in particular. And I think most of his recent work is about the evolution of knowledge spaces in regions and cities and how this evolves over time. And I'm sure also in his keynote he will address this topic more in detail. Then, of course, we have an excellent discussant taking over from David, Mary Gertler. Well, again, no need to introduce, but let me just say a few words on Merrick. Merrick is the president of the University of Toronto, and before that he was the dean of the Faculty of Arts and Science at the same university. And Merrick holds the Goldring Chair in Canadian Studies. He's very well known, of course, very influential in our field of economic geography, has done many publications on the role of innovation, creativity and culture as drivers of economic development in city regions. And I think his main interest, if you have to summarize that, is the role of institutions for regional development, how the role of institutions differ between different spatial contexts, regional innovation systems approach, how technological industrial change takes place in different geographical contexts, and the role of universities and research organizations in urban regions. Of course, he made some key publications, key contributions to our field. Just to mention the 2003 article in Journal of Economic Geography on Tacit knowledge and the economic geography of context, which has been highly influential and widely cited. One of the most cited papers in the Journal of Economic Geography, if not the most cited. And there, of course, is his book, which I always like to reread, is his book on manufacturing culture, the institutional geography of industrial practice. Well, enough about the two speakers. The structure of the session will be as follows. David will talk for about 40 minutes, and then Merrick will take over for about 10 minutes, and then we have still room for discussion for about 25 minutes. So I hope you will enjoy this session, and David, please, the floor is yours.
Well, I think it's just the afternoon, so good afternoon, everybody, and thanks very much, Ron, for that introduction. Let me start by also thanking Oxford for hosting this great event, bringing us all together. Let me extend thanks also to Derek, who clearly is largely responsible for almost all the organization at the conference. And let me also extend again another thanks to Circle for sponsoring this session. Couple more notes by way of introduction. I do owe an apology to Merrick, my discussant. I unwittingly made his job considerably more difficult by sending him a set of slides and then at a rather late date changing out a couple of slides in the interest of speaking to a somewhat more general set of notes. So I do apologize for that, Merrick, and I really hope I didn't make the job too difficult. So today I do want to talk a little bit more about flows and the geography of what we typically think of as sticky knowledge, or what Merrick himself might earlier have regarded as tacit knowledge, that kind of knowledge that is perhaps embedded in workers, in firms, in sets of institutional and organizational practices, and that often gets laid down in regions and is somewhat difficult to move or replicate elsewhere. So it is the geography and the flow of this type of knowledge that I really want to focus on today. Now, much of the work that I've been doing on knowledge complexity, is very much a joint venture, and that joint venture is being carried out with Pierre-Alex Balland of Utrecht University. The comments I want to make today on knowledge complexity really follow this roadmap. I want to try and start in the first part of the talk to remain very, very general. I'm cognizant that I'm not talking to a series of people perhaps who focus exclusively on the geography of innovation. So I will try and keep things quite general, at least for the first 15 minutes or so, and then I do have to burrow down a little bit, but I know you'll be very happy that I was told to take out a few equations. So we won't get too focused too early on. So I'm going to start by talking a little bit about the importance of knowledge in terms of the general process of economic growth. I don't think that's a great surprise to many of us. I'll then provide a brief review of work, conceptual work in the geography of invention and innovation before quickly running through some key empirical findings, Before I come on then to talk a little bit more carefully about the complexity of knowledge, some recent attempts to measure knowledge complexity of cities and individual technologies, and then the implications of that for our continued work on the geography and mobility of knowledge and spatial uneven growth. So, no great surprise, I think, to almost all of us that knowledge plays a key role. Knowledge or technology, I should say I'll use these terms interchangeably. I think if you really push me, I think of knowledge production as the development of new ideas, and as those new ideas are embodied in the form of products and processes, then I guess I might prefer to talk a little bit more about technology, but I'll use the terms a little loosely throughout the talk. But knowledge technology, we know, is key to economic growth. No great surprise, doesn't matter what economic orthodoxy you subscribe to, Marxian political economy, Ricardian political economy, orthodox neoclassical analysis, or indeed evolutionary economy. Technology is central to growth in all of those different approaches. No surprise also that doesn't really matter what spatial scale we're looking at, and over the short term or the long term, again, knowledge seems to play a very fundamental role in the growth process. Now, that's not to say knowledge is always the most important factor in growth. I'm not going to talk very much today about institutions, about industrial organization, but I do believe that these concepts interact very closely with different types of knowledge architectures, and that in combination, these different factors promote growth, lay it down in different places for shorter or longer period of times. So I'm going to focus only on the knowledge part of these different conceptual possibilities. Now, one of the things I think we can all also agree is that over the last few years, I don't want to subscribe to Friedman's notion of a flattened world, but I do think he's right in the sense that integration of economic activities around much of the world economy has been speeded by a reduction in the costs of transport and communications. Now, that means, certainly in many regions of the industrialized world, the possibilities for generating competitive advantage perhaps have been somewhat narrowed. And I think that narrowing has only brought the importance of knowledge and technology to the fore in terms of patterns of organization and possibilities for growth. Hence, the rising importance, perhaps, of the knowledge economy over the last decade or two. I think Maskell and Malmberg present these arguments very, very well in their older work, where they talk about, it's a horrendous term, I know, the ubiquitification of types of knowledge, and this process by which a lot of knowledge becomes codified over time, but that which is codified is not very valuable, and it's not really the basis anymore for competitive advantage. The stuff that counts is the sticky stuff, the stuff that is tacit, the knowledge that is complex, and that's what I want to really focus on a bit more today. Now, by way of quick review, I've got to speed things up a little bit. Where have we been over the last 20 years? I kind of think this is all very recent work, but I'm afraid that just shows my age. But in terms of thinking about the evolution of our work in economic geography on knowledge and its links to spatial uneven development, I think there was a real change in the mid to late 1990s as we started to move away from our concern with different modes of production and their geography to a much more detailed understanding of some of the factors that contribute to regional differences. Here I think, of course, of the work of Saxenian and Saxenian on industrial organization, Storper on early work on institutions in particular. And it was then that work combined with some inputs from outside the field, certainly the work of Freeman and others on national innovation systems, that really also gave impetus for geographers to start thinking about the place-specific characteristics that influence patterns of knowledge production and their adoption around certain regions of the industrialized world anyway. So here again, I acknowledge the work of Merrick along with Bjorn Aschheim, the work of Phil Cook, of course, also on learning regions. And I do think became quite clear early on, of course, that not all regions had the same degree of malleability. Not all regions were easily able to adopt new forms of knowledge and generate competitive advantage and regenerate competitive advantage in the same ways. And I think very important here then were the early case studies, certainly Gernot Graber's work on the steel industry in the Ruhr, focusing on institutional closure and lock-in, followed up by Robert Hassing's work on the textile industry in Münsterland. And much of these arguments, or many of these arguments, of course, perhaps given some more conceptual clarity by the work of Ron Martin, Peter Sunley, that drew together the evolutionary claims of path dependence, lock-in, and some of the newer work on resilience. Many of these arguments gave rise to a reworking and a re-understanding, if you like, of the relationships between economic agents operating across the world economy. Through the early work on networks of Gluckler, and then to the newer work on boson pipelines, again by Storper and Venables and by Harold Bathelt and his colleagues. Again, there's been renewed interest in the ways in which economic agents, firms, regions in different parts of the world economy, in different cities and regions, interact with one another in order to bring about new forms of technology and also aid the flow or the mobility of these new technologies around parts of the world economy. Now, as we've focused on the characteristics of regions to generate new technology, I do think we lost sight, at least to some degree, of differences in the nature of technology itself. And one of the things we hadn't done very much of in economic geography was really to think about the different sets of knowledge that tend to get produced and laid down in different regions, what I might refer to as different types of knowledge architectures, or even much more simply, the very discrete types of technologies that are produced in some regions rather than others. And I think some of the newer work on evolutionary economic geography, that pushed probably most prominently by Ron Boschmer, Kuhn Franken, as the primary architects of this work, help us do a much better job in terms of starting to think about the ways different types or subsets of knowledge interact with one another. So their notions of technological or cognitive proximity and relatedness have really helped us, I think, start to think about separating different knowledge types and then thinking about what are the fruitful or the valuable recombinations of those knowledge types, and what are the regions around the world economy that are able to produce those new recombinations that add value, that capture value, and enable them to lock in growth for shorter, again, or longer periods. There's a lot of empirical work that underpins these conceptual advances, and I have to move even quicker as I go through some of this. But broadly around the same time, by the late 1980s, honestly, if you think back and you look at what we were doing, we were pretty much simply counting the number of workers in what we thought were high-tech industries, or scientists, researchers, and engineers, again, in computing, in chemistry, in biotech, in nanotech. We were not really more sophisticated than that. And I would argue these were terrible proxies for thinking about knowledge production and technology change. It really wasn't until the early 1990s when some of the patent data became available, certainly initially in the US and then elsewhere in the world, and we started to use some other data on counts of innovation, that we started to do a much better job at uncovering the real geography of innovation and invention. I think here of some of the early work on the spatial concentration of knowledge production by Marianne Feldman and David Ordrecht, by early work on the concentration of invention in the US by Brendan O'Houlihan, one of the first geographers to use the patent data, similar work in the EU by Pachi and Usai, and then the more recent efforts by Riccardo Crescenzi and Andres Rodriguez-Posay to show just how specialized and how concentrated knowledge production is, not just in the industrialized world of the countries of North America and Europe, but also in places such as China and India. Whoops. Okay, my flicker is gone dead. Oh, here we go. So after getting an initial accounting then of the geography of knowledge production and its unevenness, attention then started to shift to the flow or the mobility of geography, of knowledge. And of course, the first work in this area that really started the ball rolling was the very well-known paper by Adam Jaffe and colleagues. Jaffe was the person, of course, that really worked very hard on the US patent data to allow us to do so many of the things that we now take for granted. But Jaffe wrote this very famous paper where he used citation information on patents that were citing earlier patents, to say something about the flow of knowledge. And his primary contribution was very geographical. He argued that what really constrains knowledge flows is distance, the friction of space. So he develops a series of nice arguments then that talk about the localization of knowledge flow. Now, there's all sorts of criticisms people have thrown at that work, and I think one of the most important comes from Bresci and Lassoni, two economists who are really friends of economic geographers, who argue that it really is not just the geography that limits the flow of knowledge. What we should also do is really take account of social interaction and look at social connections between individuals that are potentially passing knowledge. And they argue that once you look at those social connections, the influence of space declines considerably. Now, I don't want to dwell on that issue, but I am very surprised that economic geographers have not really taken that issue to task much more carefully and really gone after some new methodological possibilities that I really think does allow us to unpack the social and the spatial. At some point, you can't probably unpack all social and spatial relations, but I do think there's an awful lot of fruitful research that's possible in this area. Related work then is newer arguments in the same vein by Sun and Storper that have showed that the degree of localization of knowledge flow has only increased over time. The images at the bottom speak to other ways that we might examine collaboration of inventors over time. And here we're just looking at patterns of collaboration across researchers in European regions. The individual nodes in these networks represent European NUTS2 regions. They're colored according to different countries, and the only image I want to leave you with is the notion that in 1980, pretty much national borders constrained collaboration between inventors. By 2005, there's much more collaboration of inventors across national borders, except for the regions that are coded gray. And of course, the regions that are coded gray are the NUTS2 regions of the UK. What better color to pick on than gray in this respect? They remain stubbornly clinging to collaboration with others within the same country. So for whatever reason, they haven't reached out to engage in international collaboration the way in which some of their competitors in continental Europe have. Following this network theme, and I'm almost done with the empirical review, following this network theme, there's been a lot of interest then in trying to extend some of the buzz and pipelines arguments of Storper, Venables, and Harold and his colleagues. I know Michael Fritsch in the EU, Frank van der Wooden at UCLA. These groups are doing, or these individuals and their research groups are doing work that looks at the characteristics of different cities and attempts to understand what are the characteristics of those places that encourage, again, the formation of inventor collaborations both within cities and between them. And here we're just looking at a specialized large city in the US, Boise, in the Northwest, in Idaho. And in the bottom right, Pittsburgh, a city that's probably better known to you. Boise is a very specialized producer of knowledge, largely in semiconductor and related technologies. Pittsburgh has a much older industrial structure, much more diversified today. And what's very interesting is how in specialized and diversified cities, such as the pair I'm showing here, the nature of the structure of the relationships between inventors is so very, very different. And we're finding systematic evidence of very large structure or significant structure within cities that are specialized in terms of knowledge production, much less structure in diversified cities. This holds for both internal and external relationships. But as we start to think also about these networks of relationships, again, I want to argue that we were once more perhaps losing sight of the range of technological possibilities that were being produced in different parts of the regions of largely the industrialized world. And this is where the relatedness and some of the work in proximity really starts helping us unpack our aggregate understanding of the different types of knowledge produced in different regions. What we have here is what we call a knowledge space. It comprises nodes where each node is an individual technology class that's generated by the US Patent and Trademark Office. The green classes are broadly in the computing area, red in electronics, yellow drugs and pharma, et cetera. What's really important about the knowledge space is that the distances between the nodes are given by cognitive proximity. I'm not going to talk about the methodology that we use to actually identify the positioning of each of these nodes, but this has become very, very important in terms of thinking about not only what types of knowledge are produced in different spaces, but how the structure of knowledge at a certain time gives rise to new pathways of knowledge that are related to the competencies that have already been laid down in particular places. Not really a novel argument, no, but I think for the first time we're being able to show some of these claims much more clearly in an empirical sense. And I'm also very, very excited to be able to report there's another joint venture really between Lund, Utrecht and UCLA, which has now taken the US patent data that really has only been available from 1975 to this point, all the way back at this point to 1836. So we now have the geographies of all patents in the US over pretty much 200 years. And in the top left of this diagram, you're seeing really the first image that comes out of some of this historical work, which is again this knowledge space, in this case for the time period 1900 to 1930. And all I want you to see, to imagine, is that how the structure of knowledge space has changed over time, of course, as the range of technologies that were cutting edge in 1900 to 1930 are so very, very different than they are in the period 1975 to 2010. Now I'm going to skip a couple of slides in the interest of time and move ahead to come back to then this newer work on knowledge complexity. And the starting point again for much of this work is that earlier claim again by Maskell and Malmberg, that of course the stuff that counts is the stuff that is somewhat inimitable, that is sticky, that once more is tied to particular places, that is embodied in firms and workers. Now, again, certainly through some of the work of Merrick's that Ron alluded to earlier, we have very sound case study evidence of the importance of these different types of knowledge architectures, and in particular of the role of tacit knowledge in fueling growth or structuring different sets of possibilities in one region rather than another. And we also clearly have considerable evidence that the knowledge that is tacit doesn't travel very well. I think Merrick made that very, very clear in many of his earlier works. But given the importance of the tacit to economic growth in general, it seems to me that a significant mission in the literature is our inability to talk much more generally about how much tacit knowledge, how much complex or sticky knowledge is being produced in different regions over time. It would be great if we had some nice quantitative measures of the stuff that is sticky. And that's what I've been working on with Pierre-Alex Balland and some other colleagues over the last little while. We've taken, again, patent data for US regions, for European regions, and we've borrowed a methodology that comes from the work of Cesar Hidalgo and Ricardo Hausmann in development economics, who are very well known for generating measures of product complexity in the global economy and then looking at how different products are related to one another and how the structure of products made available in some countries rather than others give rise to certain pathways in terms of economic diversification. No problem.
I'm going to take 2 seconds. I can't apologize enough.
No problem.
Thank you very much.
Am I good? Okay. Hidalgo and Hausman lay out a method of does this mean I can actually move as well? Okay. So Hidalgo and Hausman lay out a method that I'm not going to go through in any detail at this point, but I'll be happy perhaps to talk about that by way of questions if anyone really has a burning desire to know. But they generate a very simple measure of complexity that's based really on 3 different arguments, on diversity, on ubiquity, and then combinatorial possibilities. The first argument is really that if regions are able to produce a range of technologies, a larger range of technologies, that's better for those regions than if they produce just a narrow range of possibilities. Here we're just thinking that it's better to have many competencies than few. Secondly, they argue that different competencies, different types of knowledge are more or less ubiquitous, and they make a basic argument that the less ubiquitous is more valuable. It's a simple claim that says if stuff is hard to do, not many places are able to do it. So perhaps then we can use the fact that not many places are able to produce certain kinds of knowledge to make an argument that the stuff that they produce is more valuable. The other claim, or the other function of this method of reflections, is one of combinations. And this is simply the argument that you need to be able to put together the stuff that's sticky, diverse, and ubiquitous in all sorts of different ways to make it really valuable. It's almost like a vision of knowledge that's based on Lego blocks. You know, you all get that big basket of Lego pieces. The number of blocks you have is important, of course, in terms of the generation of valuable finished forms, whatever you're producing. But getting those right, those really neat non-standard pieces, you know, the ones where you only get one in a box of 5,000, that's the really valuable stuff, the pieces that are non-ubiquitous. But the ways in which you can put together the Lego pieces themselves, the combinatorial possibilities again, are very, very important. Now, so we've taken this method of reflections and used it with data on individual patents over a series of years to start looking at or trying to estimate the complexity of knowledge production, valuing the knowledge production across cities within the US. And we work broadly with 360 or so metropolitan areas and with about 400 different technology classes. And to give you some sense of what we produce, again, I haven't given you many details in terms of methodology, but here we're looking at all patents produced over the period 1975 to 2010, and we're looking at the knowledge complexity of different cities. And to our mind, the method seems to be picking up the right cities in terms of the most complex. The darker shadings, in this case, indicate higher levels of complexity, greater levels of value. Who pops up at the top of the list? I can't reach up here, but you hopefully can see just south of San Francisco, the West Coast, California. We've got a dark brown splodge, which is Santa Clara County, Silicon Valley, San Jose. The other cities at the top in the high complexity ranks, Austin, Texas. We also see San Francisco. Santa Cruz is capturing a bit of the spillover from the San Jose area. Portland, Oregon is also a city with high values of complexity. At the bottom end, in terms of the complexity index, Columbus, Kalamazoo, Milwaukee, Detroit, Grand Rapids. Cities of the former, or what we call the Rust Belt, so the industrial Northeast, that were in a very different position in terms of complexity some considerable time earlier, and I'll come back to that issue in a moment. Now, knowledge complexity is, as this image illustrates, highly uneven. It's liable to then produce growth, we argue, in certain places rather than others, maybe not where the patents are produced in general. It might not be adding tremendous numbers of employment in these areas, but certainly the capital that's fueled by new innovation is available to firms and others in these regions to disperse in different parts of the world economy as a result of the high value of the knowledge that these cities are producing. Things change over time, not so much perhaps over short-term time periods, 25 to 35 years, but the blue shading on this illustration indicates those cities across the US that are really losing complexity quite rapidly over this current time period. And again, we see much of the blue shading being captured by the old industrial core once more in the Northeast. The cities that have done best over the recent period in terms of increasing the value of the knowledge they produce, again, are some of the cities that we associate with biotech, with new computing technologies. So once more, Austin. I'll look at the image down here. Boise, Idaho, which went from nothing in 1975 to, I think in per capita terms, the biggest creator of new knowledge in the US today. My work tells you nothing about how that happened, but the fantastic case studies of Treasure Valley by Heike Meyer tells you an awful lot about what happened in Boise. But Portland, Seattle, Rochester, Minnesota, Poughkeepsie, New York does very well, has done for a very long period of time. But let me not dwell on individual cities. Let me now jump back 100 years to have a look at what the map of complexity looked like at the beginning of the 20th century. And here we see a very different map from the one that we just looked at in terms of the red shading from 1975 to 2010. Here we are really focused on a period when the types of technologies that were the core of the economy at the time were being produced in very different places. And these were the places that we associate with the driving force of the metal bending technologies of the early automobile industry that were put in place in the beginning of the 20th century. So now the cities that come to the top, Albany, New York, Boston, Pittsburgh, Philadelphia, but Akron, Buffalo, Detroit. I mean, if you ask people about Akron, Buffalo, Detroit today, you know, if you look at the knowledge complexity values, they're going to be at the bottom of the pile. I think what's going on here, of course, is that from the early part of the 20th century to the end of the 20th century, the knowledge structure, the entire technological regimes, of course, have shifted. They've shifted away from metal bending and automobiles to nanotechnology, biotech, semiconductors. And what's going on over this time period, over the middle part of the 20th century, is that these cities here really have found themselves locked in. They specialized in the technologies of that old industrial regime, and these cities, for the most part, with some exceptions, New York has done reasonably well because of its diversity and its size. But many of the smaller cities that really locked into the complex technologies of the day are really unable to compete in terms of making the stuff that's complex at the end of the 20th century or as we move into the 21st century. And the last slide actually just gives you an indication of the key technologies, the technologies rather than the cities, that were at the top of the complexity index at the beginning of the 20th century and at the end of the 20th century. I have to confess I don't really understand what many of these different technologies are. Well, I get the television part. In the top 10, I think we've got some radio technologies also, wave transmission lines, facsimile processing, demodulators, radiant energy. But the end of the 20th century, it's all computer and related. Error detection, active electronic devices, electronic computers, memory diagnostics, data processing, structural design, et cetera, you all know the picture. The nature of technology systems, broad scale, has shifted over the 20th century. It's left the old regions that were at the top of the ranks behind. Newer regions have emerged. The older cities that were doing well, not all of them suffer from the same degree of lock-in, and new work that we're doing by, in particular, Christopher Esposito at UCLA is developing quantitative models of lock-in and looking at how different values or different indices of specialization and diversity give rise to the ability of cities to actually move and migrate in this knowledge space. And we're very excited about this work, but I'm not going to say too much more about that today. So we know to this point that knowledge is very different. It's quite heterogeneous. And we know that the geography of that knowledge production, in particular the stuff that's valuable and sticky, is very uneven. Now, that unevenness actually wouldn't matter if this sticky knowledge was mobile. Now, Merrick, in his earlier work, suggested it was not. You couldn't easily take the tacit information that was generated in one place, easily move it to somewhere else, and expect it to produce the same type of value for you. So, a question that we wanted to ask again, in a broader, more quantitative sense, using a lot more data, looking at a lot more cities and technologies, was, do we see the same evidence using the pattern data that we pulled down together today? And I do apologize for a table of numbers. But what are we doing here? We pulled down patent data for 3 periods, 1980, 1990, and 2000. And let's say for the 1980 data, we also then pulled down all the patents for 1981 to 1985, and we looked at the patterns of citations from the 1981 to 85 data back to the 1980 data. We took the 91 to 95 citations and patents and looked at those that cited the 1990 patents, and we looked at 2001-05 data and looked at citations back to 2000 patents. So I'm building a model of the probability of citation, that a patent in general cites an earlier patent. It's a little bit crude so far, but it's work in progress. What I'm really interested in is how complexity, the stickiness, the tacit nature of knowledge, if you will. I'm making a link between the complex and the tacit that I probably don't need to, but it seems silly to avoid using all the rich work done in terms of knowledge, the tacit nature of knowledge. So I'm looking at how the complex nature of knowledge influences its mobility. I'm looking at how distance influences the mobility of knowledge, how relatedness and time. Let me move quickly. I'm not going to say too much about relatedness and time, but the relatedness measure is simply capturing the technological distance between a potential citing patent and one of the early focal patents. If that distance is very small, that is, if technologies of the potential citing and cited patent are quite close to one another in the knowledge space, there should be a greater probability of citation. Indeed, that's what we see. And this corresponds to the earlier work of Jaffe, who finds, of course, if patents are in the same class, then they tend to be cited more readily. So the relatedness works. As time progresses, there is a greater probability of citation. Now, if we push beyond 5 years, there might be an argument here that we can use this time dimension to start thinking about how complex knowledge becomes codifiable over time, how it becomes more ubiquitous. That's an important issue that there's not been enough work done on to this point. Distance in general. Now, I've got an interaction term in this little regression I'm running, and to make things simple, distance I made binary, and I set equal either to 0 in the case where we're looking at a potential patent that cites, which is in the same city as a potential cited patent. So this is looking at patent and potential citations within the same city. If the distance variable goes to 1, then we're looking at the probability of citation between cities. All right? So if distance is 0, the complexity value, so we're talking about patents in the same city, what happens in terms of the relationship between complexity and citing, the probability of citation? Well, it's negative, but it's not significant. So it's got sort of the right sign, maybe. Well, certainly it has the right sign. That is, as complexity increases, the probability of citation, or the log odds of that probability, decreases a little bit. But the really interesting variable is the interaction term that's down at the bottom here. I should say that as distance increases, of course, the probability of citation decreases, which again does indicate that there is a strong spatial constraint on knowledge flow. And that's a key message. But the interaction term says, of course, that if we're talking about citing between cities, the probability of citation moving between cities, then as complexity increases, that probability decreases and it's significant. This is the result we want. So we've earlier said that the geography of sticky knowledge production is uneven. And then I said, well, that doesn't matter if it flows. These results are suggesting that the more complex the knowledge is, the less likely it is to flow, at least as measured by citation data. So, one set of conclusions, I think I've already pretty much summarized those. The geography of complex knowledge is highly uneven. That geography changes slowly over the short term, but it changes in quite significant ways over the longer term. Complex knowledge does not flow easily. Now that leads to a series, I think, of interesting challenges and questions that we can also explore. And let me just outline 3 of these. I think there's a fabulous set of issues that I know I've talked quite a bit about with Dieter Kogler on knowledge sourcing. And this is the idea that if the tacit and the sticky complex knowledge is locked into certain places, how do firms decide where to cite plants, where to locate themselves in the hopes of gaining access to particular types of knowledge? How do they distribute their plants across different places to capture different knowledges that they can perhaps combine, bring together in fruitful ways? There's quite a bit of work done on multinationals looking at knowledge sourcing type questions, but not so much looking at regions within a particular nation. So I think with these data we can do a lot more of that. It also turns out with this methodology of reflections, part of the methodology gives us a transition matrix which looks at how cities are substituting less complex knowledge for more complex knowledge. Now, this is not a random process. It is very systematized when you look at the data. It is very clear that even in some cases, those cities that are locked in, they are always trying to chase more complex knowledge. I'm not entirely sure how they know it's more complex, but they're certainly moving up the complexity ladder to some degree. Now, we think we can combine this information with the data on the relatedness between technologies to really start examining some questions about geographies of creative destruction. So that's got us very excited as well. And let me also just say, one of the things that we've been doing, and I'll leave it with this slide, is that it's quite easy for us to take our knowledge space. We know the values of complexity for all the nodes in this knowledge space. So we can take that complexity, we can interpolate the complexity values between the technology points, and then we can actually locate cities on this complexity surface. And what we've started to do is to look at how over time cities move around in this complexity surface. And this is the work on lock-in. What we find is that the cities in the less complex parts of knowledge space up at the top, the old Rust Belt cities, just do not move very much. They are still locked in. They've got the wrong set of competences to be able to take the valuable information today and really use it to their competitive advantage. The highly complex cities of today have got the right sets of competence. They're able to take this new knowledge and combine it in all sorts of different ways to create value. In some cases, however, these highly complex cities also don't move very much too. They also get locked in, but in a positive sense. They recognize they're in a good part of technology space, if you will, and there's no point in them moving. So thank you. I'll leave it there.
Well, let me begin by thanking Ron and the organizers of this session for inviting me to be discussant and enabling me to be able to pretend to be a scholar again for a few days, which is really nice, a nice change from my day job. Let me also acknowledge and thank Circle for sponsoring this session, and just to sort of reinforce what Ron said earlier about what a terrific cluster of competence in economic geography exists in that wonderful place. And thanks also to Derek and the local organizers for putting together such a wonderful jamboree of economic geography. Should say it is also a particular pleasure and privilege to be asked to discuss David Rigby's paper. I have long admired David's work, and we also have a personal connection in that I was an undergraduate at McMaster, the same university where David did his PhD, and we both worked with Mike Weber and lots of other colleagues in common. So it's, for all those reasons, it's wonderful to be in this position this morning or this afternoon. So as David has nicely indicated in the earlier part of his talk here this afternoon, the broad relationship between the production of knowledge and place continues to attract an awful lot of attention from economic geographers, from industrial economists, from innovation theorists, and others. And it also connects to very important questions for local economic development policy, which increasingly seeks to understand how one creates the right conditions to nurture and to encourage the production of commercially valuable knowledge, that is to say, innovation, and hopefully generate prosperity as a result. There's also widespread recognition that our ability to measure and to track knowledge production is still fairly primitive, and I think that came through very nicely in David's presentation. Among other things, our success in differentiating between different kinds or different qualities of knowledge remains still somewhat limited. Notwithstanding its inherent limitations, the binary distinction between tacit and codified knowledge has indeed attracted quite a bit of attention in the innovation and economic geography literature over the past 15 or 20 years. And closely linked to this, as David has pointed out, is the idea that tacit knowledge doesn't travel well because it resists codification and because its meaning is heavily dependent on the geographical and institutional context associated with its production. Now, as David notes in his presentation, this has led to the idea that places that are successful in generating innovations are characterized by the effective production of tacit knowledge. These are the places that are good at generating this kind of knowledge. It might circulate effectively locally, but it does not leak out easily beyond the local confines of such places. Now, the work of Peter Maskell and Anders Malmberg, which was cited by David in his paper and in his presentation today, is really, I think, quite important in framing this discussion. Their 1999 papers, including the one in the Cambridge Journal of Economics, made the case that the foundations for long-term economic success rested upon the ability of a place to produce knowledge and capabilities that are non-ubiquitous. And they also argued that such knowledge was likely to have a highly tacit component that made it difficult to imitate, made it difficult to replicate, and hence continued to confer advantage on those places that produced it in the first place. Now, when it comes to actually measuring the production of new knowledge, most of the action during the past couple of decades has focused on two kinds of metrics. First of all, the production of scientific publications, which can be tracked using bibliometric methods made possible by increasingly comprehensive and readily available electronic databases of publications and citations. And secondly, the production of patents, whose analysis has been enabled by a similar arrival of electronically available databases, and David's paper certainly gives you a flavor of much of the work in that vein. So the paper by Belland and Rigby, I would say, makes a very significant contribution to this literature by exploring the geographical variations in the quality of knowledge being produced in different places. They argue that much of the earlier work in economic geography has tended to focus on the quantity of such knowledge inputs, such as measurements like R&D or scientific and knowledge workers, or outputs such as patents and publications, focusing on quantity and not sufficiently on quality. And this is indeed, I think, a fair comment. Think of how many times we've seen rankings of city regions by the number of patents per capita produced by individuals or organizations in those places. And you saw at least one of those maps in some of David's earlier slides this afternoon. So the authors of the paper acknowledge that others have indeed tackled this question of knowledge quality, how one can differentiate different levels of knowledge quality by using patents and this tool of forward citation analysis. In other words, by looking at how frequently a patent is cited by other patent filers once the original patent has been granted. And among other things, the literature has identified so-called breakthrough patents in this way. And David, in one of his last slides, began to sort of use this idea in his work as well. But the approach in the core paper that is up for discussion today is to differentiate qualitatively between different forms of knowledge by developing a scheme to characterize the complexity of knowledge, following the 2009 paper by Hidalgo and Hausman that David talked about in passing. So Belland and Rigby based their work on the analysis of US patents, differentiating between 438 different technology classes used by the USPTO, and examining the geography of their production over 366 MSAs over the period of 1975 to 2004, and you've seen the maps, so you get a sense of the scale of this kind of analysis. Their definition of complexity, which is itself complex, and David, I think, wisely chose not to attempt to get into the guts of it in his presentation here this afternoon, combines data on the range of different types of technologies produced in each city, and the ubiquity of each of these different types of technology. That is, the degree of geographical dispersion or concentration of their production. I think you can see from this afternoon's presentation that this paper does indeed make several quite important contributions. It introduces into the economic geography literature a novel way of rendering a geography of knowledge production in which that knowledge is differentiated by its quality and, in particular, its complexity. Its empirical findings underscore a number of things. First of all, that the production of complex knowledge is indeed unevenly distributed geographically. Moreover, they show that the index of knowledge complexity is relatively stable over time. It's slowly changing in ways that appear to be path-dependent. But when you go all the way back to 1900, and as the slides this afternoon do, you do get a sense of this very vivid evidence of what Storper and Walker once called the inconstant geography of capitalism. And you see the kind of shift in the locus of production of new complex knowledge from one part of the country to another over a sweep of a century or more. Third, they note that those places that produce the most complex technologies are not necessarily those places that produce the most patents per capita. So, if you're thinking of a sort of competition between places in terms of, trying to measure their innovative potential, simply counting the number of patents may not actually tell you much. Really, I think that's one of the most important insights from this paper. And conversely, they demonstrate that some cities that do produce larger numbers of patents per capita are producing such patents in relatively unsophisticated technologies. And Detroit is actually a case in point here, which is singled out in the paper. It doesn't come through as clearly in David's presentation this afternoon. So they've demonstrated effectively the value and the importance of differentiating between different kinds of technologies, in particular patents, when undertaking the analysis of the geography of knowledge production. So these are important and really useful contributions, and I might say that I think it's especially important that this kind of work is being done by economic geographers and not just economists, and I think that David and Ron and others who are a part of this bigger project should certainly be thanked for doing this kind of work and acknowledged for its importance. Of course, the role of the discussant is not just to praise, but to poke holes as well. So let me poke holes in a couple of areas and then leave time, hopefully, for a discussion. So let me begin with the aim of this paper. The aim of the analysis is to identify where complex and sticky knowledge is produced. Complex and tacit knowledge, the stuff that is sticky, as David kept calling it. And to be fair, this is hard, right? This is not straightforward. If it was easy, it would have been done long ago. But I have to say that there is more than a little irony that the methods that David and Pierre-Alex use to achieve this analysis depends on patents, since patents are by definition a codified form of knowledge. That is indeed the essence of a patent, right? So this leads one to ask a number of questions, to question whether one can automatically assume that just because a particular form of new technology is not being produced in a large number of different cities, that it necessarily embodies tacit knowledge within it. I think that's an important question to ask. Indeed, the scientific knowledge that underlies patents in sectors like biotechnology or ICTs is more likely to be highly codified or codifiable, what has been referred to as analytical knowledge in the three-way typology of analytical, synthetic, symbolic knowledge made popular by Bjorn Asheim's group at Lund. And patents are most likely, I think one could argue that patents are most likely to be used to protect intellectual property when that IP might otherwise be readily imitated, i.e. when its tacit content is not very strong. That's why you need a patent to protect it. So this is a kind of fundamental contradiction that I think the authors need to acknowledge a little bit more fully than they have done to this point. David and I have already had a preliminary discussion on this over the last day or so. My second and final point is that the analysis in the paper, which is indeed very rich, and David couldn't convey all of it in his presentation here today, does yield some puzzling results that I think send some mixed signals about the optimal conditions for producing complex knowledge. So the paper reports a strong statistical relationship between specialization and ubiquity, so that it reports that on balance, cities that have high levels of specialization or low levels of diversity, that are cities that are focused on doing a few things in the types of technology they produce, tend to specialize in the production of more ubiquitous, less exclusive technologies. Cases that are offered in the paper are Anchorage, Springfield, and Carson City. And conversely, those cities that produce a highly diverse array of technologies tend to produce less ubiquitous, more exclusive technologies. And the examples that are offered are New York City, Chicago, and Los Angeles. And yet, some of the most interesting cases, I would say some of the most important cases, do not conform to this relationship. Places like San Francisco, Austin, San Jose, and Boston. These cities have a high degree of specialization, and yet a very strong focus on the non-ubiquitous, the more exclusive technologies. In other words, less ubiquitous, more exclusive technology is sometimes being produced in large, diverse urban economies like New York City or Los Angeles, and at other times it's found in smaller, more specialized cities like, say, San Jose or Austin. So what does this tell us about the local conditions under which such exclusive technology is actually produced? What are the attributes of large, diverse urban economies that tend to allow them to produce non-ubiquitous knowledge? Might it be an example of so-called Jane Jacobs effects in which innovation is stimulated by knowledge spilling over across industry boundaries, but still locally, and in which economic diversity is a source of technological dynamism? And why in some other very noteworthy cases like San Francisco, San Jose, Austin, and so on, is exclusive knowledge apparently associated with less diverse, more strongly specialized urban economies? Well, I would say that, or suggest that perhaps there are some important variables not fully represented in the analysis yet, and I know that David, this is very much a work in progress. City size is one obvious one, and it crept into some of your presentation today. I would say if there are other ways of differentiating the types of knowledge, not so much by complexity, but in terms of the kind of knowledge base, again, possibly using the analytical, synthetic, symbolic, or indeed your knowledge space categories that are represented in some of your slides, that this might help us make sense of the results that are currently a little bit puzzling. Now, in the tradition of the best scholarship, this analysis both enlightens us, but also seems to raise more questions than it answers, which is a good thing because that keeps us all busy for the next little while. Questions like, which particular aspects of the local milieu are most important in supporting the production of complex and exclusive knowledge? Is it ties to local users and customers? Is it proximity to other economic actors in different sectors, a la Jane Jacobs? Is it easy access to local top research universities and hospitals? Is it the qualities of place that attract highly educated scientific and technical labor? So what is it? What's operating? I think the answers are likely to be, well, it will indeed vary from case to case, and therein one is induced to add further complexity to our understanding and our explanations. So notwithstanding these matters, this paper really offers a novel and very stimulating perspective on a familiar and still very important set of questions in economic geography and beyond. And for that, the authors are indeed to be commended for advancing the discussion significantly. Thanks very much.
Okay, thank you, Merrick, for those mostly very generous comments. The two more critical questions that you raise at the end, on the first one, certainly guilty as charged. Patents have all sorts of problems, many problems that we know quite well, and they're in a general sense, of course, they only capture a portion of the knowledge that's produced in most economies. And the argument you made about patents themselves being codified form of knowledge, absolutely. I can't run from that critique. I'm just really left with the problem of give me another possibility, and I'll run with it. And I mean that really. I mean, geographers, I don't think have done as much, economic geographers have done as much, say, as the economists in getting out there looking for other data possibilities, for looking at new ways of developing proxies, measuring variables of one sort or another. I think we have to do much better than we have done in the past in that respect, but still, yes, I'm guilty as charged. On the second question, specialization and diversification. Yeah, I think what I tried to do today in terms of presenting some more general information about where we've been in terms of the geography of innovation led me, I think, to bring together some different arguments that are not solely from the paper with Pierre Alex, and I might have confused a little bit some of the discussion about the relationships between complexity, specialization, and diversification. I think you're absolutely right. Certainly the cities that we see at the top of the list of complexity at the end of the 20th century are certainly not the largest cities, certainly in terms of population across the US, so San Jose, Austin, as you reported, Santa Cruz, Rochester, Minnesota, Portland, Oregon, and elsewhere. And they do have very specialized knowledge bases. So this does lead us back to, I think, a more detailed consideration, again, of, I don't want to say let's return to the old specialization and diversity debates, but it does raise the issue that if you're more focused, if you're more specialized, that at least in the short term or near term, if that near term might stretch out over 30 years or so, again, that focus, that specialization is probably a good thing, of course, as long as you've bet on the right types of specialization. If you're still as specialized as Detroit, Akron, Columbus, Buffalo, and the old cities from the Rust Belt, then of course it's a massive negative in terms of your ability to generate competitive advantage. Just very briefly, to make room for a couple of other questions, in terms of other variables, what is really astonishing about the method of reflections, however opaque and weird it actually is, it does better than anything else at removing the influence of scale. And it was in part intended to do that. And I'm not quite sure how that happens, but it absolutely removes scale effects from data. And in that respect, it's incredibly useful because there's very little else that does that for us in economics or economic geography. Yeah.
Okay, thanks. So, well, we have still 15 minutes left for questions, so please raise your hand if you have any. Richard, over there. Please, could you say your name and your affiliation before you start?
I'm Richard Sherman from McGill University, so thanks David and Merrick for this paper and the comments. I'd like to go back to what Merrick said about patents, because I think that's a wider problem in economic geography. Even in the talk that was given today, there's a very quick slippage between knowledge space and what you're studying, which is in fact patents. And we know the problems with patents in terms of we're not quite sure what they measure. There's also, because a lot of our knowledge about the geography of innovation comes from patents, basically it's very skewed knowledge. And I think that this, I acknowledge that you can't really use any other data, but what would be good is exactly what are you looking at and what is not being looked at. To sort of give a bit of room for people who are studying innovation in other contexts, because otherwise our geographic imaginary about innovation is exactly what you described, big cities, Silicon Valley, which is basically technological innovation in particular industries, which sort of reminds me a bit of the obsession with high-tech sectors back in the 1980s. So I think you did a great job with the data you have, but what exactly are you missing? Or maybe you don't know.
Okay, I still have three others. Let's first collect some questions. Erik.
Thank you very much for this fascinating lecture on this rigorous data set. I think you very much built on the work by Hidalgo and Hausman. They correlate or show that there's a strong correlation between complexity and economic income or economic value, so GDP. You're pretty silent on value generation, so you very much focus on knowledge creation and complexity, but do you assume a one-to-one translation into economic value and that the geography of knowledge production goes hand in hand with the geography of economic value creation? I think there's something else in between that, so several mechanisms and actors. So is this a new research agenda? Are you silent on that, or are you working on that?
Okay, yeah, please, Susan.
I'm Susan Christofferson from Cornell University. I was struck by the absence of a parallel to the financial transformation that's accompanied the technological transformation. So I'm wondering how you respond to the movement of startup firms, for example, particularly in the biosciences, but in other areas, to certain finance markets, San Francisco, Boston, so that the technology appears to be occurring in those particular financial centers, but it's actually produced in Columbus, Cleveland, Rochester, New York.
Okay, over there, Koen Keulings.
Koen Keulings, University of Cambridge. I liked your presentation very much, and I had a question. I'm always puzzled by Zipf's law or Guibret's law, which suggests that growth rates of cities are random. And it suggests that it seems that it must be related to picking the right technology. And have you thought about that relation? Because in particular, if you diversify, you have more chances of getting the right technology, so you would be able to insure, and you would expect that those cities are less volatile than cities that bet on only one technology.
Okay, I think then the last question by Jerker Moddison of Circle, Lund University.
Thank you. I very much enjoyed your presentation. I'm looking forward to reading the paper. I know you said in the beginning that you was asked to, or you decided to remove your equations from the presentations. But I was still wondering if you could, without equations or models, explain a little bit more how you measure complexity. You say it's a function of diversity, ubiquity, and combinations. And I can see that ubiquity and combinations are fairly straightforward to measure, but diversity in terms of cognitive proximity and so on is much, for me at least, much harder to really see through what kind of indicators. If you can explain that in a simple way, would be really nice.
Okay, let me try and respond quite quickly. On Richard's point, again, what do we get with patents and what do we miss? As Merrick indicated, we probably miss quite a lot, and as most people that work with patents recognize, that they do capture only specific forms of knowledge production. Let me refashion my response a little bit to say that I think as economic geographers, again, one of the things that we don't do that I think would allow us to sort of combat the charge that's being leveled, and I take the charge in a very positive way, is that we've never really put together, to my mind, teams of researchers that have got really quite varied sets of skills within economic geography to go after a specific question. So, for instance, we haven't ever talked about combining some of your primary data analysis, your case study analysis, with perhaps some of the quantitative expertise from secondary data sets that I might be able to bring to the table, together with the conceptual skills that Ron or Merrick or Michael or others might be able to offer us. And hopefully, by working together in these sorts of teams, which is I think much more common in many other disciplines, we might be able to confront some of the absences in either the way we understand knowledge production in geography. So yes, I'm clearly missing a lot of stuff. If I knew what that stuff was, I'd try not to miss it. But I need help, and I think the best way of getting that help is to reach out and form these partnerships. And I think there's lots of us who'd love to be able to do that, and maybe we should put together some sort of listserv or something. Okay, on Eric's question, value generation. Yeah, I have to say I'm getting very, very nervous as I muck around more and more with the patent data, about really what does it mean for long-run regional growth? Because I think of a place like San Jose, which is sort of at the top of the list in terms of the complexity index, and it's a fabulously rich area, but you think of where most of the jobs are in terms of the employment that's generated by the technologies that have been produced by firms in that region. They're all around the world. We just heard in a talk the other day about I think by Changwon, the amazing numbers of people that are employed by Foxconn, so this Taiwanese firm that has these giant factories across China employing, we're told, a couple of 100,000 people in each factory. I don't know very much about that, but I know Foxconn is one of the firms that's putting together components of the iPhone. So that the job generation, certainly, that we see resulting from much of this even highly complex knowledge is not laid down in the same places. Now, that's a problem. A lot of the values captured and returned to these same places, but if we're thinking in terms of what's going on in labor markets and whether just generating complex knowledge is a good thing for workers who are well paid, but also workers who are moderately paid or even low paid, then things get a lot grayer. And certainly we need to do a lot more work in terms of understanding what the connections are between the knowledge generation in certain regions, the employment, the value creation that goes on elsewhere. I'm really not sure how to do that, and especially when there's an international component. I mean, I'm always struck by the fact, having done a little bit of work on trade, one of the things that I think, honestly, the global production networks people have got to confront is they just don't have the right data. There are no trade data around the world that allows them to really identify what the value that gets produced in one country and then move to another. You know, there's a team of 30 economists who wrote a paper exactly on this. These are orthodox economists clamoring for better trade data so we can actually figure out what gets produced and what value gets added in one place, and when this stuff gets moved somewhere else, what gets added, when it goes somewhere else, what gets added. We've no way of breaking into that puzzle with the stuff we've got, with the data we've got at the moment, but perhaps this means bigger teams again and more primary data collection. Susan, on financial change as well as tech change, I've been quite surprised, actually, just as a quick aside. We often associate patents with manufacturing activity. It's quite surprising in recent years how many patents are given out for new financial algorithms. Just as a quick note. But yeah, I hadn't really noticed. I don't know much about the financing of the knowledge production that goes on. I've got this naive vision, of course, that we've had a couple of successful entrepreneurs in a firm and they've sort of built themselves up by the bootstraps. The firm's got bigger, they have more value, they create more knowledge, and it's this process of, this cumulative process. So I've clearly got to do a much better job in terms of thinking about, yes, the sources of finance that underpins much of the initial stages of knowledge production before perhaps it does get locked into these new cities across the US, where then through increasing returns or other mechanisms, it does seem to get locked in for greater or shorter time periods. Boston, New York are really interesting cities because Boston is one of the key cities that does keep cropping up from the early 20th century to the late 20th into the early 21st century. New York was pretty high up at the beginning of the 20th century, but now it's sort of a middling city in terms of complexity by the end. But Boston is a very special place. That's all I can say. I don't know if that means that it's specialized in a variety of diverse areas, so it's been able to sort of regenerate itself from one time to another, but it does appear to have that characteristic. I'm not sure I'm doing such a good job in answering these questions. The growth of cities, Gibrat's law, diversity, specialization. What can I say? Well, what do all cities want? All cities want to be absolutely 100% specialized. There's no question about that. That's what everyone should want. But if you're going to do that, you have to pick the right technology to be specialized in, right? The problem is you don't know what that right technology is going to be tomorrow. So diversity is, of course, important just because it provides some sort of hedge against getting it wrong. But it would be interesting, and I'm not sure if I'm picking up the point correctly, I think it really would be interesting to start thinking about how we might value that hedge and how we might try and figure out, well, what sense does it make actually not to put all your eggs in one basket? And I think we can figure out in a fairly trivial quantitative sense how to actually figure out what it means to be specialized and diverse, especially when we put together these very, very, very long-run data. I think we can have some nice attempts to go after those sorts of questions. In my notes, I've got number 5, method. Can you help me out? My notes, sorry. Oh, yes. Got it. Got it. No equations on this one. Oh, come on. Gosh, this clicker is... Oh, I've gone the wrong way. No. No. I'm 2 away. Okay. So how does it work? In a very, very simple sense, we've got cities, C1 through C4. We've got technologies. Cities go to 366, technologies to 438. We've got a bipartite network. We can operate, so what we have for every single patent, we know what city or cities it's created in, what technology or technology classes it's placed into. So we can form a series of links between the technologies that are produced within different cities, and we can operationalize that in a form of a simple matrix, such as this here, 366 rows for the cities, 438 dimensions. I'm not going to get too much more technical than that. What do I mean by diversity? Well, take a city, which is one of the rows in this matrix, and just count the ones. So that tells you if the sum is 4, then the city produces 4 different types of technologies out of this set of 438. Better to have greater competence than lesser if you just restrict yourself to the diversity argument. So diversity is captured very, very simply. Ubiquity is also captured very, very simply. The technologies are columns. Just go down the column and sum the ones. If there's lots of ones, lots of cities produce that technology. So it's more ubiquitous. What do we do with this stuff? Well, we do some mucking around. We take that original matrix of binary matrix of zeros and ones, we row standardize it, make a matrix A, we column standardize it, make a matrix B. So we're capturing some of the diversity and some of the ubiquity arguments, and then we end up with we find the product of these two matrices in C, and then I hate to say it, we find the eigenvectors of matrix C. The eigenvectors of matrix C are basically centrality measures. So C is a column stochastic matrix, and their so the eigenvectors, or the second eigenvector, which captures most of the variance in C, is just a set of centrality measures. And it turns out this algorithm, this is a different way of presenting the method of reflections, which actually is just an iterative procedure that achieves the same results. This methodology is almost the same as Google's PageRank algorithm, which is worth 25 billion and actually is patented. And the result of the PageRank algorithm for Google is simply a series of measures of the centrality of each website on the internet. And what we're building here is in our centrality measures, we're capturing the centrality of cities or of technologies in this city technology matrix. Actually, their eigencentrality, so their centrality that's valued in a certain way. So I'm capturing the diversity, I'm capturing the ubiquity in a rather convoluted way, but that's as good as I can do. Thank you.
Okay, thanks so much, David, for your excellent presentation. Also, Merrick, thanks very much for your wonderful comments, and of course also for the very good attendance and for your participation in this session. Thanks very much, and a special thanks again to Derek for making this all possible. Thanks a lot.